Okay, so let me just share my screen. One moment. So hold on, hold on, hold on, hold on. So share the screen. I would have to share the file only. Yeah. PowerPoint. Okay, so let's start the designs and show. Okay, so let's see what we're gonna do here. Give me 1 moment. I have to sleep this thing here. Okay, this is what we have here. What we're gonna be doing today is gonna be mainly about picturing. Like I got to have like what you call it again, a visual representation of what I mean of data. We're gonna do some visual representation, and after that we're gonna keep going on some other stuff. Let me see. Am I doing the right chapters? I'll make sure that I was on the right. Yeah, okay, that's fine. So this is the first note I want to talk about. Is like we need to, whenever you do statistics, there are a couple of stuff that you need to understand. So we're gonna be doing a 3 main things. First of all, we're gonna do something called. First, you're gonna collect. You need something called data. Okay. Once you get the data, you need to collect the data. You're gonna collect it. Once you collect the data, you're gonna do something called organization. Okay, you're gonna organize the data. Sorry about it. Organize the data. Then after the organization of the data, you need to do something called interpretation. Interpret the data. Okay. So the data will be given to as raw data, right? So so just like this one, say you're gonna organize using some chart. So that can the chart will be like something easier to see. Okay. We can use something called distribution frequency. This one say the distribution that I described the value frequency count. So we're gonna be doing, whenever you have the data, you need to know how many times they show up. This is what I call the frequency. And then after that, you're gonna be able to organize it. So let me just quickly show a quick example of data. I'm gonna go back to these 2 questions after that. Let me see if I can just go to the the next slide. So let's see. So, give me 1 moment. I wanna skip a slide here. I did it last time. Here we go. So let me go to that slide 54. Okay, here, in this example, we see that this is a data that is given to, as you can see, it's like a raw data. So what we can do, we need to find a way to represent it, a visual representation we can do. So the first thing I like to do is like to show it like that. For example, I need to know what type of number do I have. So I can say, so I do something like this. Okay. So I'm gonna have the answers here, but that's fine. So I'm gonna do a graph like this. Just 1 moment, just in case the answers show up. Let's put it down here. So what type of data we have? If you look at the full-time job, we got let's call this one the type of data, and I'm gonna just call this one the frequency. Okay, this is called the frequency. So the frequency will be how many times you see a data, how many times you see a data. Okay, that's what we call the frequency. So suppose I say number 1, how many times do I see number 1 repeated in this data? I would say this is 1 right here, 2 over here. So as you can see, it's repeated 2 times. That means the frequency of 1 is 2. Then let's look at this next number, number 2. How many times do I see number 2 in the data? If I count, this is 1 over here, okay? Then I got 2 over here, then I got 3. So you repeat 3 times. And then how many times, like number 3, how many times is repeated in the data? Let's see, got 1 right here, 1, 2, 3, 4. So you repeat 4 times. Then you're gonna go with number 5. I'm sorry, number 4. So how many times is number 4? Got 1, 2, 3, okay? 4, 5. 4 is repeated 5 times. Then you're gonna say number 5. How many is 5? How many times you see number 5 on the data set? You got 1, 2, 3, 4, 5, 6 times. So you just repeat it 6 times. Then you got number 6. You just happen the number just look similar, but yeah, there are other examples that do not look similar. So how many times do you see number 6? Let's see. This is 1, 2, 3. 6 repeated 3 times. Then you got number 7. Oopsie. Number 7, that's gonna be a hard one because you get to my number 7 is repeated how many times? As you can see, number 7 is only repeated twice, 1 and 2. So if you add all of these numbers together, this is what we have. So I'm gonna do the graph a little bit higher. I know there's another graph thing coming on. So this is the type of data here. And then this is the frequency. This is got a 1, then you repeat twice, and then 2 is repeated 3 times, and then 3 is repeated 4 times, and then what is it again? What is it again? Like 4 is repeated 5 times, and then you have 5. It was repeated 6 times. 6 was repeated 3 times, and then 7 was repeated about 2 times, right? So if I add all of these numbers together, let's see how much it give me. 2 and 3 is 5, 5 and 4 is gonna be 9. 9 and 5, that's gonna be 14, 14 and 6, that's gonna give you 20, and 3, 23, 25. So here I have 25 data set. So if I come here, as you can see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25. Okay, so they have to match. So we have 25 data set. So here, it makes us see that, as you can see, and look at the table quickly. The table adjusted. It seems like the number that we put the most. Can anybody tell me the number that we put the most in this data set? Anybody can say that?
5.
5 is repeating the most, right? Thank you very much. So before you can see it, whenever you look like the whole data, we ask a bit harder to see. But now we can see that 5 is repeated the most. There's something else you can add to it also. Something called, again, this is called frequency. This is the number of time the number is repeated. Frequency. Okay, frequency. I'm gonna go over them again. And then there's another one. I'm gonna use a different color for it. This one is called a relative frequency. Let me see. Different color. Let's do purple. So the relative frequency goes that way. I'm gonna put RF for relative frequency. So it'll be relative frequency. This is what you do. To get the relative frequency, what you do, the formula is the following way. is how many number a number is repeated over the total number of frequency. The formula goes like this. You can say RF is equal to frequency of an element F over the total number of frequency. That symbol that you see here, it means sum. Okay, that's mean if I wanted to do the relative frequency for the first one, for 1, I would say that's going to be 2 divided by 25. Okay, let me just do this right here. Okay, so if I use my calculator and if I now do 2 divided by 25, do you know how much it's going to give you? 2 divided by 25. How much is that? Anybody? Let me see, I have calculator here too.
0.08.
0.08. Thank you. That'll be 0.08. So let's do this little exercise and find the rest of them. So we're going to do now 3 divided by 25. Okay, so that's what I do. Then that'll give you 3 divided by 25. That's going to be how much? That's going to give you 0.12, right? I just did my calculator. That's going to give you 0.12. Then that'll be 4 divided by 25. That's going to give you 0.16. So I'm going to skip the steps so you guys now already know what I'm doing. 0.16. Then 5 divided by 25. That's going to give you 0.2. Okay. Then 6 divided by 25. That's going to be 0.24. And then 3 divided by 25. That's going to be 0.12 again. That's going to give you 0. And then 2 divided by 25, that's going to be 0.08. Notice that if you add all of these numbers, if you do 0.08 plus 0.12 plus 0.16 plus 0.2 plus 0.24 plus 0.12 and plus 0.08, that's going to give you barely 1. Okay, a number close to 1. Okay, so it doesn't give you 25 again because it's going to be like 25 out of 25. All right, that's why it gives you 1. And then notice something I can do also with the relative frequency. There's something I can do. I can say this one can be like 8%. I can say this one is like 12%. I can say this is 16%. This will be 20%. That will be 24%. 24%. That will be 12%. Now be 8%. Everything give you 100% if you add them up. Okay, so this is what it means. That means that 5, let me just type it instead, 5 appear 5% of the time. No, I'm sorry, number 5, yeah, number 5, I can say 5 appears I can say 24% of the time. Okay. So I can say that the percentage of 5 is 24. I can also say the percentage of 5 is 24, right? So anybody, what will be the percentage of number 7? What do you think the percentage of number 7 will be? Thank you. So what are the 2 numbers with the lowest percentage in the data set? Or the number that appear the least in the data set? What are the numbers that appear the least? Okay, thank you. Because 1 will be 8%, also 7 will be 8%. All right, thank you very much. So if you can see the second largest number in the data set will be number 4, because number 4 appear 20% of the time, or I can say 0.20. And this is what we call a relative frequency. Okay, so whenever it's a frequency is a frequency divided by the total number of frequencies. Like 1 appear 2 times, that's mean you're gonna do 2 divided by 25. 6 appear 3 times, you're gonna do 3 divided by 25. The 25 will be the total of frequency. This one is gonna be sum of the frequency. All right, any question about that? Any questions about that? I'm looking at the chat, nobody say anything. Can I have everybody? Let me see. Am I no questions? Okay. I'm just checking if I have my volume on. Okay. So there's another way to present the same data set. It's called a dot plot. Okay. So the dot plot is very simple. I'm just gonna go up here. I don't have space to do it here, but I'm gonna do it with you right now. So in a different example. So let's go back to slide number, what was it again? Right here. So before I talk about it, so this is what happened. What I just show you is like is a table, just to give a basic idea of it, which help us to organize. Okay, and then we call it data we organize. Then after we do some interpretation. When at the time that we use the percentage, we are doing interpretation. When I say which number will appear the most, which number appear the least, we're able to do that by just looking at the data itself. But what I want to do now is to do something visual, okay, of what we just did, the visual representation. Okay, so with the visual representation, there'll be 3 things we're gonna be able to understand. Something called symmetry. So we want to know whether there's a symmetry in the data set. Okay, that's very important. Okay, we want to know whether there's something called outliers. This is whenever there are values that are too far, okay, or too close, something like, no, not too close, too far. This is called outliers. Okay, the number that are too far away, outliers. Okay, so we want to know, is there a most common value or most common range of values? So this is also part of it. You want to know whether there are values that are the most common, and then also the least common. All right, so that's the idea, that's the idea behind that. All right, so let's do the visual presentation. We just did one over earlier today. I'm going to show it to you. While we're talking about the dot plots here, is the same idea. Earlier, we just did an example. For example, if I show that little table here, in which I put, this is the type of data, and it is the frequency, right? I can say, for example, let's put 1 is repeated like 3 times. Let's put that, I'm just doing a different example, okay? That's on this one from my head. And then you got 2 is repeated like 4 times. And then I can say 3 is repeated like 2 times, and so on, right? And I can say also 4 is repeated like 1 time. So I can do, to do this is like a table, I just show you. To do a visual representation, something called a dot plot is also visual representation of that. So what I'll do a straight line like this, and I'll put 1, 2, 3, and then 4. And then on top of each other, on top of which I put how many times I see number 1. I see number 1 3 times. Okay, I see number 2 4 times. I see number 3 2 times. Okay, I put 2 right here. And I see number 1 1 time. Okay, you guys see the idea? Okay, so let me quickly show you the one we just did earlier today. That is already done. So where is he? Where are you? Where are you? So this one here, it shows something like this. So we just did that number. This is, they have two values. One is for full time, which has a word on it. So I don't want to delete it just in case you want to have it as well. So the one is for full-time people, the other one is for part-time people. As you can see, and for the full-time, I was in for the one for the full-time. As you can see, for the full-time, one will appear 2 times, 2 appear 3 times, etc. Right? So let me show you something quickly. So let's go to the next slide. Okay, come on, go to the next slide. Right here. So if you look carefully, one, we did say this is we're doing for, don't worry about the one on top. Okay, I'm talking about the one for the full times, this one only. As you can see, one appear 2 times, so we do 2 dots. Okay, that's why I say earlier, 2 appear 3 times. Okay, and so on. So we also did the same thing. This is this one for the full timers. We also did the same thing for the for part timers. Okay, so here, number 1. You see, this is 1, 2, 3, 4, 5, 6. That means 1 appears 6 times for the part-timers. It's and so on. All right. And then the last one, which is number 5, 5 appear only once. As you can see, for the part-timers, 5 appear only once. You don't have to do the tables together like this. We did it like this for the sake of just showing everything at the same time. But as you can see, he give me an idea of the data. If I can ask you, for the part-timers, which number repeat the most? By just thinking at the example, which number repeat the most for the part-timers? 2. 2 repeat the most for the part-timers, as you can see that, right? And then the one that repeat the least is number 5. And for the full-timers, just like we said earlier, the one that repeat the most was 5. Okay, so you don't have to do this table together. We put it here together just for the sake to help you understand the idea behind that. Okay, so let me go back to my notes. And just go right here, go to the front, to the top one. So we talk about dot plots. Okay, a dot plot is the chart, that's a definition, that contains a dot for each data value. We just did that. Okay, where is my cursor again? So what's the benefit for showing of doing the dot plots? It shows individual data values. Okay, as you can see, it has to be like whole numbers. Like 1, you can see that 1 appear 3 times for well. Okay, it's easy to spot outliers. You know what an outlier is? An outlier we just said earlier is a number that is very, very far away from the data set. It's called an outlier. Okay, a number that is very, very far away from the data set. I'll be talking about that later on. At the same time, it describes the distribution visually. So it shows you what kind of distribution we are. I will be talking in deep what we call distribution. Mainly, when I want to talk about distribution, I want to see something called that is symmetry. Okay, symmetry. That's what I'm looking for. That's what we're looking for. So what by doing a symmetry, we need something called a bell shape. Something that's a bell shape. A bell shape look like this. Okay, that's a bell shape. In that case, we say this is symmetric. Okay, and the middle part right here, as you can see, divide the thing into 2 parts. That's what we call a symmetry. Okay, there's a line of symmetry right here. And then the one side copied is the copy of the other side. It's actually, you're looking at yourself in the mirror. Okay, that's symmetry. But there's a bad thing with the dot plots. It's like, I'll be talking about something called a bar graph, which is easier, and also pie chart, that would be easier. And then this is only valid for something that is have very small numbers. Okay, if you have huge data set, it's not a good idea to use dot plots. If you have a huge data, it's not really a good idea to use dot plots. But if you're using a small data set, then that's fine. Okay. Let's show you on a quick example in which you have more than one data. Here, this is a dot plot. Okay. I don't know if you guys can see it very easily. It might be hard, but at least you can try. Okay. Let's ask a couple questions about this data, this dot plot. Okay. I'm asking you right now, do you guys see any outlier, something that a specific number that is completely far away from everybody? Do you guys see something that is look like an outlier? Yeah, something close to 100, 300. Thank you very much. Okay, so that's what happened. As you can see, something close to 300 is an outlier. This guy is like everybody else will be together. Okay, they like, okay, we hanging out together. Okay, that's what happened with everybody else. Okay, now let me go back up quickly on top here. I'm gonna bring that back the notes right here. So here I just show you something called the table. I show you a table right here, and then I'll also show you the dot plots, right? And I also say something that is also very important. I say that is as common as a bar and a pie chart. Why take a bar? Let's talk about the bar chart a little bit. This is what happened. This one will be easier to do. So what I'll do, this is how I'm gonna be doing. So first of all, I'm gonna do a bar chart for that one here, for this example over there. So what I'll do, I will have two axes. One of them will be for the type of data. This is the type right here. Right here, I will say this is 1, 2, 3, and then 4. And the next one, that will be the frequency right here. Okay, frequency, remember the frequency is going to be a whole number. The relative frequency is the percentage or decimal number. We just talked about it earlier today. When I did the example with you for the full timers, I did a table where I have the frequency with the specific numbers, and also the relative frequency, in which we have like decimal numbers and percentage. So that's what allows us to do some interpretation of data. So now on that side, I'll put the frequency. So this is how I do it. So I'll say, look at the highest number that we have, and the frequency table is 4. So I'm gonna say this is, for example, I will say I can say this is the frequency right here. I can divide it like this is like 1, 2, 3, and then 4. Okay. So I do the graph. So for 1, we have 3. 1 appear 3 times. So what I'll do a little bar. Let me use a different color for it. That go up to 3. Okay, so let's do the bar that go up to 3. Okay, so this is the bar. And then the next one we have is 2. That'll be 4 times. So I'll do a bar that go up to 4. So sorry about my right, I'm trying my best. Up to 4. And we put a bar right here. So this one appear 4 times. This is the most common one because here you have to show the distance number. Okay. Next one is number 3 that appear twice. So the number 3 appear twice. So right here. And then number 1 appear once. Okay, so right here, once, right here. Okay, so this is what I call a bar graph. Okay, that's what I call a bar graph. Then whenever I refer to back, that's what it means. Okay, so let me just go ahead and give you some idea about it quickly. Okay, so let's talk about this is what also called a bar graph. So Now I just put something that say frequency. Whoa. I just talk about bar and I put frequency. Look at my bar graph here. My bar graph here doesn't have any, there's a space here between each number, between each one. This one we call a gap. Okay, there's gap between each number. If there's no gap, we call it like a frequency table. Frequency. I mean, sorry, histogram. It's kind of the same thing, but you just say histogram. Okay. So what is a histogram? Histogram is a type of bar graph. Okay, as you can see, the same idea. We have two axes. We got the one for numerical, 1, 2, 3, some stuff like that. And then the vertical axis will be for the frequency of data. Okay. And then what we do with the frequency table, it does group data into bins, also interval or classes. So here, we're gonna call them also bins or interval or classes. These are definitions that we need to know. Bins, okay, intervals or classes. Okay. So based on that, it's easy to visualize the distribution. So that's just a presentation of a frequency of a histogram. Okay. But you also can talk about bar graph is the same idea. So just a presentation. Okay. So there's no need to worry about anything here. You just say this is an histogram. All right. Okay. This is an example. Oh, by the way, does anybody have any question? Again, just a definition. Anybody have any question on that? Okay, so nobody have any question. So here just an example, give you an idea. So we're just gonna have to read it. Okay. So so what happened here? As you can see here, the numbers go. Okay, that's something I also have to. I will explain to you this about this in a later on, because it's when I was still doing a little bit of introduction. As you can see here, from here, we got from a smaller bin. You got, let me use a different color. Right here. From here to there, you see how wide is the bar? That's when you have a smaller width here. The width is smaller. Okay. Compared to this one, we have a bigger width. Okay. This one from 0 to 5. Here we got 0 to 5, but it's like kind of like 1/3 of it here. All right. So this is why you say the smaller the width, the more detail you're gonna have. Okay. Smaller width show more details. You have smaller, you're gonna show more details. Too small a width show too much details and will not clearly display the main feature. So it's gonna be, as you can see here, it doesn't show too much of the feature of the data. So this, remember, this is what I'm looking for. I'm looking for something called symmetry, the bell shape if needed, or some kind of a shape. If I use a bigger thing right here, I can have a kind of a shape over here, something like that. Something like I can have a shape I want here. While this one here, because you got two dots right over there, you see, you can have something like this over there, something like that. Okay, kind of hard to see. All right. So it's best. I mean, in the exam, you will be given some of the width, but sometimes you're gonna have to calculate them. But most of the time, if it's a hard concept, you're gonna be given those you're gonna be given those width. But as you can see here, if it's the smaller it is, the more detail you have. Okay, in that case, it's best to use an interval. All right, so let me just show it quickly up there. No, that's fine. Just let's keep working. This is something else. So again, just the definition. Just remember that the smaller the width that you're given for the histogram, the more details you're gonna be showing. Okay, that's what you have to remember here. So earlier I talked about something called relative frequency. So here we're just gonna go over the definition. We just talked about it earlier. So a relative frequency is a histogram where the vertical axis represents the relative frequencies or percent or the frequencies. So you're gonna have to compute the relative frequency by dividing the frequency by the sample size. We just did that earlier today. So if I can go over it a little bit again. Okay. So this is, as you can see, some of them with just definition, and sometimes I'm gonna have to intervene myself and show you something completely different. Just we don't stick only with the definition. Okay. So earlier we did something like this. So if I give you a quick example, that's going to be the probably you're going to call this one now, just like we know earlier, I'm going to call this one a class. Let's not call it class right now. Let's just call it type. Okay, a type. And that'll be the frequency. Let's put like 1, 2, 3, and then let's put like 5. Let's put like 4, 6, 7, something like that. Okay. So to get the relative frequency, if you add these numbers, 7 and 6 will be 13, 13 and 4, that's going to give you 17, no? Right? 17. So I like numbers that are easier. So to get the relative frequency, what you're going to do, you're going to say 4 divided by 17. And then that's going to give you a decimal number or a percentage and so on. We just did that earlier. So any question about that? We just talked about it earlier. Okay, now there's something I want to point out to you. Let me see. If I have an example here, if I can get another example, that can show something with only the with just only the also with a class. Let me see. Okay, that's fine. So let's go that way and then time. Okay. So if there's no questions, let me keep working. So let me just erase that. We can have more room for this. So you say the relative frequency histogram always has the same shape as the frequency histogram. The frequency, the vertical axis is just changed. So I think that is the best time for me to show the histogram, the table for the graph for the histogram. Okay, here we have an histogram. Now, some of you can say, why the number looks so different here? Okay, so why the number looks so different here? As you can see, we have like 1, 2, 3. Here we just present. This is what happened with the frequency. It allows us to work on intervals. Okay, so let me just quickly, if I can just go, let me go back first to that example. Hold on. Let's see. See pen. Let me just add quickly something. If I have space here, I didn't create the space. Okay, let me do something right here. Suppose I have a data like this. Suppose I say let's put 3, 5, 7, okay, and let's put like 3, 5, 7. Again, I can say 15, 16, 18, and then I put like 25, 24. Let's see. I forgot to put the pound in this thing. And then I'll put 24 again. And I put 31, 38, and then 39. Okay. So let's put a couple more. Let's put 8, 10, let's put 9, 17, and then let's put 24 again, etc. Okay, this is what we have. So what I can do is to do a table first. So in that case, because as you can see, the number looks so weird, so I cannot do a dot plot here. I cannot say this is 3, how many times I see number 3, kind of hard. So what in that case, what I'll do something called a class or bean. Class. Okay, that's a C right here, class, not das, class. And that'll be the frequency right there. So what I'll do, I can, for example, say number between 0 and 9, from 0 to 9, number from 0 to 9, then number from 10 to 19, number from 20 to 29, and then number from 30 to 39, okay, and so on. So I'm gonna say how many number you see between 0 and 9. As you can see, you got 1, 2, 3, 4, 5 numbers are between 0 and 9. That'll be 5 numbers. How many number between 10 and 19? Got 1, 2, 3, 4 numbers between 10 and 19. And then how many number between 20 and 29? 1, 2, 3, 4 again. At least put an extra one to make it more spicy. Let's put 27 too. 1, 2, 3, 4, 5, 6. 6 number between 10 and 20 and 29. And how many number between 30 and 39? That'll be 3 numbers. Okay. If you add these numbers, that'll be like 9 and 9. That'll be 18 numbers in total. This is what we call using the class. We get the frequency. If you do the graph for it, it goes like this. So you do this one like this and that. Okay. So we're gonna have my first reaction will be from 0 to 9. Okay, 0 to 9. Then there'll be 10. And I mean 0 to 9. Okay, and then 10 to, let's do that way instead. Because the way the number are set up, I can just say something like this. Let's go. I can sort of say 0. Okay, okay, 0 to 9, and then 10 to 19. Okay, etc. Right? So I can just say I can just put 10 right here and say 10. Okay, that will be 20, 30, and then 40, something like that. Okay, so what I'll do between 0 and 9. So I know I say 9, but just bear with me because we're gonna be working on them anyway in the soon. So this is what I can do. So let's put the frequency again. The highest one is 5, is 6. So I'm gonna go something like this, probably like I can say this is 2. See, that'll be 2, 4, 6, something like that. Okay, and then that'll be 8. Now between 0 and 9. So 0 and 9, I can say this is like I can say this is like 5. 5 will be somewhere around here. So what I'll do my graph from all the way to 5. Okay, right here. Okay, then I'm gonna do 10 to 19, which is gonna be 4. From between 10, that as you can see, 10 to 19 is between 10 and 20. So I'm not to worry about too much. That's gonna be 4. Okay, so I'm doing now is histogram. So I'll do it without any gaps. Then after that, I'm gonna do 6. Oh, the other one is 5. What did I do? My mistake. 5 is all the way here. My mistake. This is 5. Okay, this is 5. This is 4. The next one is 6. 6 right here. Okay, that's 6. Then after that, you have 3. So 3 is right here. So this one is what you call the frequency table, frequency distribution. Okay. So now we're going to do the same thing for the relative one. So the relative one, what you're going to be doing is going to be 5 divided by 18. Okay. And then so on. 4 divided by 18, 6 divided by 18, just like we said earlier. So let me do them. So 5, erased. 5 divided by 18, that's going to be 0.277. Zero 0.278. So about my handwriting, 0.278. 4 now, 4 divided by, where's my thing? 4 divided by 18, that's going to give you 0.22 something. That'll be 0.222. Okay. Then I'll be clear that 6 divided by 18, that'll be 0.333. And then 3 divided by 18, that'll be 0.167. So we do the graph again for that one, kind of the same thing. I'm going to put 10 right here, 10, 20, 30, and then 40, okay? So they are the same. The highest one is 0.333. So what I can do, I can just do something like this. I can just say, let me see. This will probably like 0.4, 0.4, then 0.2, 0.3, 0.2, okay, 0.1, etc., and 0. Okay, 0 is very important to put a 0. Then other way, you can do the same graph again. The first one that we do is 0.278. 278 is like close to 3, all right? So I do something like this, 378, 0.278, closer to 3. So we'll go something like this. This one is 2.222, is a little bit underneath of it. It's not going to be perfect, so I'm trying my best to show the graph. So as you can see, the graph kind of look the same. For the next one, it be 0.333 is above 0.3. And then do something like this. And then the next one will be 0.167, which is under. That'll be right here. So as you can see, the graph are the same. Either the relative frequency or the frequency itself, the graph will be the same. That's what I wanted to say earlier. The order of this is just to say that. Okay, so I'm going to keep working. So this is what we have here. This is a relative frequency, just like I showed you earlier. It doesn't have to be a specific one, the same one I gave you. Here we have the intervals from this one, say from 0.7 to 0.8. Okay, from 0.8 to 0.9, 0.9 to 0.10 to 1 point, etc. I know you got the idea. So this is the question I'm going to ask you now. So can I say this is about women soccer players? I don't want to ask a question because I don't want to ask a question about it. This one saying that half of the women are between 0.7 and 0.8 goals per game. You see, this is 50% right here. That's mean about 50% of the game, about 50% of the time, the women score between 0.7 and 0.8 goals per game. All right. Okay. So, and also there's a there's a small number of exceptional players. So small, I mean, that's mean most of the exceptional players, that's mean somebody you have 1.4 games or more. So we're gonna go right here. Here will be the expression players. Let me see. Where's my cursor? I'll my cursor again. Okay, as you can see here, people with 1.4 goals or more, there are there's a small number of them. But most of the women will have 0.7 or 0.8. I mean, 50% of them will have goal between 0.7 and 0.8 goal based on that graph that is given to me. All right. So when I have this graph in front of me, I can make interpretations, I can make inference, so I can have an idea. But if I'm given the word data itself, it's hard to really work on it. That's why it's good to have that visual representation. It makes me understand better. Not I know some of you don't are not really good with graph, but you won't have to grab it most of the time. I'm just gonna give them to you. You're gonna have to study them anyway, only. Okay. So I have one more concept to work with you about. So not this one just say what is the, I just talk about it here with I'm sorry, I just talked about that earlier today. I just show you that the relative frequency have the same thing, kind of the same idea. But look at something here. This is a little bit better here to understand. You say, whenever you use frequency histogram, you want to emphasize on how many are in each one of them. You use relative frequency if you want to talk about proportion or percent. Proportion is what you call the decimal numbers. These are decimal numbers. Decimal numbers, no, not decimal numbers. These are the fractions, okay? Fractions, not decimal. Okay, you can go for it too. I'm sorry, sometimes I talk a little bit fast. So that would be the fractions. And this one will be the percent. We already talked about the percent or the decimal, kind of the same idea. Okay. So if you want to focus about frequency, I mean, number of people, number of things, then you use frequency histogram. If you want to talk about proportion or percent, you use relative frequency. The difference over here are clear, as you can see here. Let me just go back here. Here we have, here, as you can see, we have decimal numbers here. While earlier we had, what is it? We have some specific number right here. See that? They're not the same thing. Okay, so I hope you guys understand that part. Don't confuse relative frequency and frequency distribution. Okay. Now, the last topic for today, I'm going to let you go. And okay, it's something called a stem and leaf. Okay, the stem and leaf. You tell me what are these things right here? I put over here, as you can see, each one say 147, 2, etc. Here, it's like having, if you can see, it's like having the dot plots. Okay, let me just show. This one is like having 14. It means 14, 17, something like that. That'll be 22. See that? 25, 25, 28. Okay. Now it'll be 32, 33, 34, etc. That'll be 40, 40, 40, etc. And that last one be 15. That's the idea behind that. Okay. So what you need to do here for the stem and leaf, the number in the front, like whenever you use the 14 right here, this number is what you call the stem. And the number on the right side is called the leaf part. Okay, the leaf. That's the leaf part. Okay. That's the part. I say part. When they say part. Okay, that's the leaf. So whenever you do that, that's another way to represent that asset as well. So in the exam or in the homework section, I can show you something like this, and then this is gonna be my data given to you. So it's not Chinese when I show you something like that. Okay, let's talk about it. So the leaf is the last digit. The stem contains all digits before the last digits, and then before the last digit will be called the stem. Okay, it's showing individual data values. Okay, same as histogram, but being with a power of 10. So example, the five zeros show that there are 5 classes with 40 students. Which, I mean, let me just do that quickly. So if you want to do just like this one here, you can also present it into dot plot. You can, this is like 1, 2, 3, 4, 5. You're gonna say 1 appear 2 times. A number between, you see that? 1 appear 2 times. Then 2 appears. I mean, a number with the with a stem. I mean, the number in font. I'm talking about the stem here. Here in that case, this is the stem. There'll be 4 times. Okay, and then 3 appear also 4 times. And then 4 appear 1, 2, 3, 4, 5, 6, 7 times. So I'm gonna have to do 7 dots. This is if I just show just the stem. The other one will be the leaf. And then 5 appear only 1 time. This is the dot plus. You also go do a histogram. Not, it doesn't have to be histogram because I have to use I'm gonna use a bar graph. So for 1, 2, 3, 4, 5. Okay. So I have to make sure that my system is working fine. Okay. So the highest number that we have, it was 7. So I can just put this one is like 2, 4, 6, 8, something like that. Okay. It's not perfect, but I'm trying my best here. See, let's see. Here is that. So 1 is repeated twice. So I'm going to put a bar graph for 1. 2 is repeated 4 times. I'm going to put another bar graph for 4. 3, if the other one is also 4. Wow. Sorry about my cursor is messing up with me. As you can see, the class will be kind of boring all the time, but we're going to be able to do our best each time. This is called statistics. Okay, and the other one is 7 all the way to the top, and the last one is 1. Okay, or if you want, you can just put the number. This is going to be 2, this is going to be 4, 4, that'll be 7, and that'll be 1. If you want to, you don't have to. And this way you have the bar graph. Okay, for the stem and leaf. Okay. All right, then I'm gonna have to stop here because I think I saw so much. Whenever I come back, you guys owe me 15 minutes. Whenever I come back on Thursday, there are so many things I need to see with you. Make sure you have your coffee with you because I'll be talking a lot and I'll be very boring, but we try our best to stay awake, right? We're gonna try our best to stay awake, correct? I think I already lost everybody. Okay, I see this chat now. So you guys are awake. Thank God you guys are awake. Usually people start sleeping around that time, but that's fine. When I'm in the classroom, people already start sleeping. So you guys are in Zoom. All right, bring coffee with you next time. All right, I'm gonna stop here. See you guys on Thursday. If you have any questions, please stay. I would like to answer a question. I'm very available right now if to talk to you if you need to. Okay. So let me stop the recording. Oops. What did I do? Stop the recording.